Okay, we're back again with this molecule. So using it for everything. Again, just to refresh our memory, remember I said hydrogen usually is white, but I put it here so we can see it. Then I made these two blues that represent bromine or bromo. My purple is representing iodo, and the green one represents chloro or chlorine. Again, remember we talk about clockwise, counterclockwise, and we know that I or iodo has a higher priority than uh, bromo. So this become an S. Remember carbon had the priority of 3 and 4. Hydrogen is away from us, so we can ignore it. So this became done many times, S and S. Now the mirror image of this molecule, again we drawn it before, is R and R. Now Fischer came and let me write his name here. Physicist, chemist, and he was a sugar chemist, and he proposed to display a three-dimensional structure, like a sugar structure, on a paper a little bit different, not using wedge or dash, but basically lines. Now again, we have to learn this Fischer projection is important. So he proposed the line or bond going away from us that is from the hydrogen to this carbon here. We show it on top. So this top part of the Fischer projection represent bond going away from us. This carbon-hydrogen bond at the bottom also shows the bond is going away from us. These 4 bonds that's shown here and here, remember there's a carbon here and carbon here. So those 2 carbons are the center, right? The center. So iodo, and bromo, remember we showed the bromo with the little blue thing coming toward us. So these 2 bonds coming toward us. These 2 bonds coming toward us. So both of all these 4 bonds are coming toward us. So there is not a dash or wedge. We understand that these 4 bonds are coming toward us. These 2 bonds going away from us. Same thing for the mirror image. If you look at the mirror image Fischer projection of this, also the I and bromine, chloro and bromo coming toward us, the 2 hydrogen going away from us. So we like to use the number system. Remember the number system we used before? So this would be bond between the carbon iodo would be 1, carbon bromo would be 2 for the first carbon. So we only do 1 carbon at a time. Carbon is 3. Now in Fischer projection, we learn different ways. So the way I like to teach it is number 4. So we're going to practice on this. Number 4 has to be on top. Remember number 4 in the previous dash and wedge was away from us. It's the same thing as that. So if number 4 is on top and the bottom, we can ignore it. That's the key. 4 has to be on top or the bottom. We can ignore it. We'll find a color here. Use green. Use red or something. So this carbon number 2, we ignore number 4. Now if I connect 1, 2, and 3, is S. If I do the same thing for carbon number 1, remember this is 1 atomic number, and 4 we can ignore. 1, 2, 3. Also, it's counterclockwise is S. Do the same thing on the right side. 4, ignore. 1, 2. Oh, I forgot the 3 here. 1, 2, 3. R. Look at this one. 1, 2, 3. R. So they're a mirror image of each other, remember? And they're enantiomers. So the enantiomers, again, they are same compound. And the only thing they're different is they rotate the polarized light polarimeter opposite each other. But melting point, boiling point are the same. Some molecules, I told you, smell a little bit different. We can tell it, actually, the smell. So it is an enantiomer. So let's pause for a minute and look at the diastereomers for these two Fischer projections. So again, we need to practice and learn Fischer projection. I'll be right back. Okay, I'm back. So I did the same thing here. I kept the carbon number 2 the same. I'm sorry, carbon number 2, yes, carbon number 2 and carbon number 2. So they're still, we'll do in a second, they are mirror image of each other. But we're going to look at the carbon number 1. That's the difference. So let's get the structure to the left. Again, in Fischer projection, if 4 is above, right, and 4 is below, based on the Fischer projection, we can ignore it. So if I look at the 1, remember this? Oh, I forgot about this one. Number 3, bond priority 3. So we ignore 4. So this is 1, 2, 3. So it's like before, is S. If you look at this one, 1, 2, 3. Also S. 1. Remember 4 we ignore. 1, 2, 3. S. Let's look at here. So again, 1, we can ignore 4. So we have 1, 2, 3. Oh, I forgot the 3 here. 1, 2, 3. R. So these two carbon, remember each corner is a carbon? We don't show the C, by the way. We never show the C. So these two carbon are a mirror image of each other. We cannot say enantiomers because an enantiomer is really for the whole molecule, not for a carbon. These two are mirror image of each other. So let's look at the carbon number 1. We know carbon number 1 in this structure is S. So we have again 4, ignore. 1, 2, 3, 1, 2, 3. Oh, it's S. So again, like before, we have a S and a S the same. S and a R for these 4 carbons. So they're not mirror image of each other. One carbon is mirror image of the other one is the same. And Fischer projection is easy to see. If you look at this carbon and this carbon, you can see the pattern is the same. Br, Br, Cl, Cl. And we know if this was S, this is S. The pattern is the opposite. We know I and I close to each other, Br and Br away from each other. If this is S, we don't know. But if it's S, this should be R. So again, like before, if these two, one is mirror image of the other one is the same, the carbons, they are diastereomers. Diastereo. I almost have trouble saying that. So diastereomers are different molecules. They have different melting point, different boiling point. They're not enantiomers. They're not mirror image. So they're different, and we learn how to identify diastereomers. Thank you.